We're going to check out the application of the lids wheel and the market considerations to a flip-flop design. So let's start by thinking about what's in a typical flip-flop. It has two parts, a sole and a strap. The sole, or footbed, in most common types of flip-flops is made out of a foam, though the huge variety of flip-flops means that there are lots of options like rubber, leather, or other plastics. The most common foam types used are polyurethane and ethylene vinyl acetate, or EVA. Leather is also a fairly common choice. Because materials choice is one of the most important areas that a designer can influence, let's look into some of the basic materials used for shoes. Shoe companies are becoming more and more aware of the impact of their choices. We found one study that we'll reference a few times in this section for Deckers, the maker of simple shoes, that created a predictive impact model for their shoes. That is, designers could enter material types and specifications and see what environmental impact those choices had. Now, not every company will have commissioned something like this, but with the growing interest, there is more and more information available to all the designers. Polyurethane is made from oil at the most basic level and manufactured by mixing polyols and isocyanates, i.e. chemicals, in certain proportions. Heat is used in the production processes, which requires energy, and hazardous chemicals and vapors that workers can be exposed to. Factory fires are extremely dangerous in health terms and can put local communities at risk. Solvent residues pollute the wastewater of the factories. It is biodegradable, but it's still toxic to aquatic life. EVA has been used extensively to replace PVC. It's better in the sense that it doesn't use chlorine, which can lead to the formation of dioxin, a very carcinogenic substance. However, it's not recyclable. It's made predominantly in low-cost Asian countries, though this can probably be said of most shoes, because the U.S. imported nearly 85% of the shoes that it bought in 2007 from China, according to the American Apparel and Footwear Association. A life cycle assessment of one model of EVA flip-flop found that about 95% of the environmental impacts from its entire life cycle came from the materials production and assembly. It's estimated that an EVA flip-flop offers about 3 months of solid use before it falls apart, say 1 summer. Leather requires significant inputs from livestock. Not only the use of leather at the factory, but the feed required to raise cows or pigs for their leather, and the significant fertilizer and pesticide inputs to growing that feed. Not to mention the surprisingly large global warming impacts the animals have due to their bodily processes. One life cycle assessment of leather footwear found that raising cattle had the largest global warming effect of any of the life cycle stages. Timberland has done studies of its shoe products and found that leather really does drive the score. In fact, because of the major impacts associated with leather that you only begin to realize when you take that life cycle view, a study of footwear design choice impacts listed leather as a material to generally avoid. The study also noted that wool, for similar reasons as leather, should be avoided, and suggested that hemp material is a far superior choice over leather or wool. Just like Arthur and Lindsay pointed out earlier, if it's a plant and it grows, it's renewable, and probably more sustainable. One plant that doesn't work this way, unfortunately, is natural rubber, which the study also noted should be avoided, because the rubber for commercial purposes is usually grown in large plantations that require a ton of fertilizers. So now, in the spirit of taking a life cycle view of the design process, let's check out a simple picture of the value stream for polyurethane and EVA. Although the manufacturing details are different, they essentially follow the same path to becoming flip-flops. You can visualize what these stages mean too. Now let's dive into each stage in the value chain to see where you as a designer can influence the sustainability of these flip-flops. Oil production. It's a pretty well-known story that we rely very heavily on oil for most aspects of our lives, from transportation to plastics. Unfortunately, there are some real tough consequences environmentally and socially. Oil production has a large environmental footprint. You can see the kind of expansive land use required for oil wells and a disgraceful human impact in some parts of the world. These pictures are from Nigeria, where oil production is very poorly regulated and fraught with frequent spills and toxic effects. displacing people and ruining their environment. When designing, the first two stages of the lids wheel approach can help you think about the materials choices. Maybe it's possible to avoid or limit the use of petroleum-based materials. For the actual foam production, you may not have as much influence here, but ask your procurement department to do their homework and see what they can find out about the processes used at the plants that would produce your design and whether there are alternatives. Manufacturing of flip-flops is mostly done overseas, where oversight of working conditions may be difficult. This step involves cutting the parts, assembling them, and packaging and labeling the finished goods. Some of these steps may not be an opportunity where you can have a ton of influence, but if you're able to design a product that has the potential for highly efficient patterns and therefore reduced scrap, you may very directly be reducing materials waste and use. Importantly, if you've designed your product with minimally sufficient packaging, you can influence how it's produced at this stage. Are toxic glues needed to seal boxes, for example? Or can you display your flip-flops on a single recycled board hook rather than a box or a plastic bag? While it's not relevant for the flip-flops that we're discussing, one manufacturing example provided in the study mentioned earlier is that the cold cement process used for rubber has a much worse environmental impact than conventional vulcanization. Cold cement is a process to attach the shoe upper onto the shoe last using water-based glue, but it is much more energy intensive than vulcanization, which achieves the same goal by using ovens. This type of insight is counterintuitive, but once you have all the information, you can act on it. Warehousing. Again, unlikely that you as a designer would have oversight of logistics and energy efficiency at a warehouse, but the previous discussion about packaging can greatly influence this phase by reducing volumes and weights, and thus cut down on the need for inventory space, which will drop directly to the bottom line as cost savings, and reduce fuel and emissions and costs needed to move the goods. Transportation can end up being a relatively small piece of the overall footprint of a shoe, but if you can minimize its impact, in addition to focusing on other key sustainability areas, go for it. To some degree, all the choices you've made up to this point will affect the retail value. While there is definitely growing demand for greener products, you may choose to highlight the qualities that make your flip-flop green instead of simply just that it is green. For example, marketing the durability may be as attractive or more attractive to someone who lives in their flip-flops. Durability will pay dividends as it reduces the use phase impact of the shoe and also builds customer loyalty in a product they can rely on.
Sometimes I feel like throw my hands up in the air. I know I can count on you. Sometimes I feel like saying, Lord, I just don't care.
Use. Even more so than retail, it is the design choices you've made up to the point of sale that will affect sustainability impacts during the use of your product. If you have used recyclable packaging, it's more likely that it won't be sent straight to the landfill. If you've made a durable shoe, the wearer will get more use out of it. If you've made the shoe of material that can be reused, it may actually have more than one life of use.
When I get older, I will be stronger. They'll call me freedom, just like a waving flag. And then it goes back, and then it...
Your design and labeling choices that, for example, label your product as reusable or recyclable can limit the waste it causes when it's no longer in use as a flip-flop. Cottage industries are springing up to turn flip-flops into other consumer goods. For example, there's a company called Unique Eco which takes flip-flops washed up on the shores of Africa and uses local labor to turn it into other products. By guiding your consumer towards one of these choices for what to do with their flip-flops, you can help diminish landfill and incineration wastes. Think of the end of life of your product from the very beginning of your design process. So now that you've gone through the entire value chain for the sole of the flip-flop, you can take that same logic and apply it to the strap. For example, you know that going with a hemp-type strap is going to be more sustainable than going with a strap made of rubber. Keeping these rules of thumb in mind will help you to make these decisions consistently and sustainably in the future.